Hello guys, and welcome to this video today. Please, in today's video we shall be looking at the correction of the Cameroon GC A level that's further mathematics question number 2, and it is based on differential equation. So guys, stay tuned because we are going to be highlighting the possible errors and the corrections that you can make. So guys, please, if you've not subscribed to our channel at this point in time, please just hurriedly hit the subscribe button so that you're going to see all our contents that are going to help you in your upcoming exam. And guys, please have in mind that if you don't subscribe to our channel, guys, you'll be unable to see all our other content because most of our content is now have been restricted only to our subscribers. So guys, hurriedly hit the subscribe button so that you see everything. And guys, feel free to email me or send me a WhatsApp message or through Facebook if you have any difficulties that I can attend to. I'll be so happy to attend to. So let's get started. Okay guys, the first part of the equation now simply wants us to get the value of lambda. This is it. To get the value of lambda, or this guy looks like x. To get the value of lambda for which, yes, we have to get the value of lambda for which y equal to lambda x e raised to the power 2x is a solution to this our differential equation. Okay, now you must also understand that if y equal to lambda x e raised to the power 2x is a solution to this DE, that therefore means that it should be able to verify this differential equation. So now the second derivative of this our function plus the first derivative minus 6 times the function itself should be the same like 10 e raised to the power 2x. So that's the notion in which we are simply going to use to solve this our problem. Alright, let's get started. Let's dive straight into it. So I'll just roll a horizontal line here and let's dive straight into it. Okay, let's start. We are going to start by differentiating. So we're going to differentiate this guy. We're going to have our dy by dx, which is the same as, we'll keep lambda constant since lambda is a constant. Then we open square bracket. Differentiating x, we're going to have 1, keeping e to the power 2x constant, plus now keeping x constant. Then we differentiate e to the power 2x. We're simply going to have e raised to the power 2x. Then now the chain rule says we multiply by the derivative of the power, which is 2. Good. So this is the first derivative of our function. Okay, now the second derivative, we're simply going to have our d squared y by dx squared, which is the same as, we are going to keep our lambda constant again, lambda into, we differentiate this guy, we are going to have 2 e raised to the power 2x, then plus, we are going to keep this 2 constant, then differentiating x simply gives us 1, keeping e to the power 2x constant, plus now we keep x constant. This is going to be x. Then the derivative of e to the power 2x is simply e to the power 2x. Then the chain rule says multiply here by 2. Good. So this is what we have. Then now we are simply going to bring forth everything here and substitute into our original equation, our original differential equation, such that this is going to translate into, we'll just be opening the brackets alongside. So this is just going to be 2 lambda e raised to the power 2x. Then the lambda comes inside. This is going to be 2 lambda, then plus 2 lambda e raised to the power 2x. Then now plus 4x lambda e raised to the power 2x. Good. So this is exactly what we have now. Then now plus the derivative of the function, which is just going to be what we have here, which is going to be lambda e raised to the power 2x. Then now plus 2 lambda x e raised to the power 2x. Good. This is what we have now. Then minus 6 times the function itself, minus 6 lambda e raised to the power minus 6 lambda e raised to the power 2x. Then I'll just end up with x since I forgot to put it. Good. Then I'll just continue it here. This has to be equal to 10 e raised to the power 2x. Good. So the first case is that we are going to see that all the e to the power 2x, they are going to cancel all through. All the e raised to the power 2x, they are going to cancel all through. Good. Then now we are now going to have 2 lambda plus 2 lambda gives us 4 lambda. So we are going to have our 4 lambda here. This and this they've given us 4 lambda. Then this is now going to be 4x lambda plus 2x lambda, right? This is just going to be 4x lambda plus 2x lambda gives us 6x lambda. Good, 6x lambda. Then we are simply going to have this way. This is simply going to be minus 6 lambda, which in this case is giving us, we have 10. Good. Oops guys, there's some slight error here. This is going to be negative 6 lambda x, right? Then this is 4x lambda, then this is 2x lambda. So this we should expect, not this place, not this, I'm sorry. So we should expect to have 4x lambda plus 2x lambda, which should give us 6x lambda. Please, I'm sorry guys. Then minus, this is still going to be 6 lambda x, so it's going to be 6x lambda. Good. Then now this is going to be our 2 lambda plus 2 lambda, which is going to give us 4 lambda, plus then this lambda, which is going to give us 5 lambda. Good. Then that is equal to 10. Good. So that this 6x lambda and 6x lambda, they can cancel out already. That therefore implies that our lambda turns out to be, we divide all through by 5, we are going to have our lambda to be 2. Good. So this is the value of our lambda. All right. Now, since we have value of lambda now, in fact, that is what the first part of the equation was demanding that we should do. So the value of lambda in this case is going to be 2. Good. Then the next part of the equation now simply wants us to find the general solution to the differential equation. Now, we should know that the general solution simply consists of the complementary function plus the particular integral. This y equal to lambda x e raised to the power 2x, where we found the value of lambda to be 2, is simply the particular integral. So all we need to do now is to find the complementary function. And the complementary function is simply being found as we look at this second derivative and we represent it to be a constant squared. Let's just say the constant is m. You can take a constant to be anything. This is m squared. Then plus the first derivative, which is going to be m. Then now the next derivative, which is going to be minus 6. That should give us 0. Good. That therefore implies if we solve this guy now as a quadratic, we look for two numbers. If we multiply, we are going to have negative 6. We add, we have 1. I'm sure those numbers must be negative 2 and positive 3. Good. So we have minus 2 and positive 3. So we simply factorize this guy to be m plus 3 into, we have m minus 2, that is equal to 0, such that we can have the value of m to be, we're going to have m to be negative 3, or we can have our m to be 2. So these are the values of m that we want to find. Now the complementary function, the general solution for the complementary function now is simply given as e raised to the power, that's 2 times this guy, 2 times, that's this 2 times x, plus now b, which is a constant, times e raised to the power this other guy, which is negative 3x. Good. So this is our complementary function. Great. So now having the complementary function now, it can permit us now to write a general solution for this differential equation. We can write out that our general solution, which turns out to be, implies our y is now going to be the complementary function plus particular integral. So it's going to be a, where a is a constant, e raised to the power 2x, plus b times e raised to the power negative 3x, plus now the particular integral, which is going to be y equal to lambda x e raised to the power 2x, but the value of lambda was known to be 2, so this is going to be 2x e raised to the power 2x. Good. So this is the general solution in which the equation wanted us to find. Okay, now the next part of the equation has simply given us our y to be 0, then divided by the x to be 5, then x equal to 0. Then they want us now to find the values of these constants a and b. Okay, they've given us our y to be 0, so this y turns out to be 0. So we are now going to have 0 which is equal to our x as well is 0, so e raised to the power 0 is 1, so we are just going to have our a here, plus x is 0, so we are going to have b. Good. Then this x is 0, everything dies to 0, so we are simply just going to have our y to be we're simply going to have everything. We are simply going to have a plus b, which is equal to 0. That's our first equation. Okay, now then let's go ahead now to differentiate this our function. We are simply going to have dy by dx, which is the same as a is a constant, so we simply differentiate e to the power 2x to have 2a e raised to the power 2x. Then the same for b, we're going to have minus 3 b e raised to the power negative 3x. Then plus, now we'll keep the 2 constant. We have 2 into differentiating x e raised to the power 2x. We are simply going to have e to the power 2x. We did that initially, plus 2x e raised to the power 2x. Good. Such that they said our divided by the x in this case is 5, so we are going to have 5, which is equal to our x is 1, so our x is 0, sorry, this is just going to be now 2a. Then our b as well, our x as well is 0, so this is going to be 2a minus 3b. Then x is 0, this everything here goes to 0. X here is 0, so we're going to have e to the power 0, which gives us 1. 2 times 1 simply gives us 2 plus 2. So if we arrange everything now and solve, we are going to have 2a. We are going to have 2a, then minus 3b, which is now going to be, we send to this, we are going to have 5 minus 2, which is 3. So we can now solve these two equations simultaneously. So yeah, so guys, if we solve this equation so well now, you will agree with me that we are going to have the value of a, we are going to have a to be, if you solve so well, you should expect to see a to be negative 3 on 5. Then we are going to have our b in this case is going to be 3 over 5. Good. So these are the values of a and b. Good. So guys, the next part of the equation is simply telling us that we should solve the differential equation x dy by dx plus 2y equal to 4x squared, and they've given us conditions that when y is equal to 2 and x equal to 1. So guys, please, I really encourage all of you guys to have writing material such that as I'm solving the equation, you're also solving along and following up, such that when a similar question like this is being given to you, you shall be able to solve it without any stress. So guys, please, if you don't subscribe to our channel at this point in time, just hurriedly hit the subscribe button. And guys, if you're watching from Facebook, just hurriedly follow our Facebook page, so that we're going to have so many followers to join us. And guys, you can only watch our next video if you're subscribed to our channel and you follow our Facebook page. So guys, shout out to you, and let's dive straight into it. Guys, the next part of the equation simply wants us to solve this our differential equation given that y is equal to when x is 1. Okay, now guys, we see that to solve this differential equation, we see that the variable separable method cannot help us to solve this problem, because it is not possible for us to separate the variables together to bring all the x's to one side and the dx as well as the y and the dy's. All right, now guys, we see that to solve this problem, all we need to do is just simply to use a suitable integrating factor. And to get that suitable integrating factor, we simply have to arrange this differential equation into a form that we can easily obtain the integrating factor. And by so doing, now we must make sure that the coefficient of the gradient function here must be what? 1. And the only guy that is disturbing it from being 1 now is simply what? Is simply our x here. So we'll divide all through by x, dividing all through by x, all through by x, all through by x. Now they will cancel. We simply have our dy by dx plus 2 over x y, which is the same like now 4x. Good. Then our integrating factor now if is simply going to be e raised to the power of the integral of the coefficient of y, which is 2 over x dx, and this is going to give us e raised to the power 2 times the natural log of x, which you can bring the 2 to the front. Now if we bring the 2 to the front, we're just going to have e raised to the power ln of x squared, which the e and the link will cancel, we are going to have x squared. So now we simply multiply this differential equation now with x squared. So we are going to have our x squared now dy by dx plus now the x and the 1x it will cancel. So we are going to have 2xy, which is the same like 4x cubed. Good. So now in this case now, guys, we simply recognize that this is in a form that we can easily recognize it, right? Because I'm seeing x squared divided by the x, which is the derivative of y, then 2x, which is the derivative of x squared. So we can write this guy as d by the x, that's the derivative of xy. Then this is the same like 4x cubed. Good. So we have this in mind now. We can easily go ahead now and integrate all through. Integrating the derivative of a function. Oh my god, this is x squared, not x, please. This is x squared. So we are simply going to have our x squared y, which is the same like 4 times the integral of x cubed. Good. And by so doing now, we are simply going to have our x squared y integrating 4x cubed. That's simply just going to give us 4/4, then x raised to the power 4 plus our constant of integration c. So since y is 2 and x is 1, we simply plug everything into our equation and solve. So that implies that x is 1, right? Y is 2. So we're going to have 2 times 1 square, which is simply 2, which is the same as the 4 and the 4 cancel, which is the same as 1, since x is 1, plus c. That implies our c in this case is equal to what? 1. Good. So we simply bring forth everything into this our original equation and solve. So we're going to have our x squared y, oh this marker is crazy, which is equal to x raised to the power 4 now plus c is what? 1. Good. So guys, this is our differential. This is the function in which